Greetings, salutations, welcome to Tier 5, back with my usual substandard quality of videos, back on the webcam. What are you going to do? So, AMD recently revealed to the world their new up-and-coming line of Ryzen Zen 3 CPUs, and if the market material / tables on stage were to be believed, I'm not going to go through the specs. I mean, they've been done to death by the usual tech YouTubers, plenty of videos to look at. But if that's all true, if what AMD is saying about these Ryzen 5000 series CPUs, then Intel really need to be quivering in their diamond-studded procrastinating boots, as I'm experiencing buyer's remorse with my 10900K sat here. But before that, this video is brought to you by me and Autodesk, kind of, but I'm not selling anything. What? If you're thinking about subscribing to a new Autodesk software license anytime soon, or if you're soon to be renewing an existing Autodesk subscription that you've already got, please do consider using my Tier 5 paid referral link, which is in the description. That'll take you to your local Autodesk store. It won't cost you any more to subscribe using my link, but I'll get a little cut of the commission, which will serve as vital support for the channel. Thank you very much in advance for your consideration. Links in the description. Unfortunately, I'm not going to get a sample of these AMD CPUs. I've kind of just surrendered to that fact at this point. It's not going to happen. I'm not going to get a hold of one. I'm not going to be able to demonstrate them on the channel, showing how Autodesk Inventor works with them, you know, VRED and Fusion 360 and all the three, you know, AutoCAD, whatever, you know. It looks like these new AMD CPUs potentially are going to be king of the hill for 3D CAD applications. Sure, take your gaming, whatever. They look like they're going to be great for gaming, but for what we care about, which is 3D CAD, professional workflows, they're looking like they're going to be the best of the best. What I thought I'll do instead is, in anticipation of these CPUs coming out, I thought I'd go over my InvMark benchmark suite again and show you a new test, just to build up a bit of hype. Because I think my benchmark test will come out around about the same time as the Ryzen CPUs will, if not slightly before. So, you know, let's just get a little bit of excitement up. You know, there will be people who want to test the new Ryzen CPUs on this test. So it's kind of, you know, it's all related. It's all interlinked. So already on the channel, I've shown you the FEA tests that I've got built into here. And by the way, if you've never seen this before, if you've no idea what this test is, I'm designing my own Inventor or Autodesk Inventor benchmark test. Autodesk Inventor, if you've never heard of that, is a SolidWorks type application. It's of similar ilk. SolidWorks is more popular, it's more well known, but Autodesk Inventor and SolidWorks are very much the same thing. This benchmark application will test multiple modules within Autodesk Inventor: simulation, graphics, drawings, modeling, almost everything within it. And it's done by someone who's got, well, as much as anyone really at this point. So yeah, that's what this is all about. And it's nearly finished. And I want to show everyone all the tests, but I don't want to put it all out there too early and then have the excitement where, you know, wither away before it's actually released. So I've already shown my finite element analysis test. I'll show you it again here, but I've also got an extra test. Let's jump into it. Okie dokie. So I'm playing a video of the test rather than actually doing the test because the test itself kills the computer. That's what a benchmark test does. It absolutely canes the PC, so my screen recording software crapped its pants. Anyway, this is the first test. It's the Parametric study finite element analysis test. So my benchmark test kicks in, starts the test, begins a timer, and then it times how long it takes this benchmark test to complete. And then these parts here have 10 different sizes. The real world use case for this is a designer plugs in 10 different sizes for these parts. The software then performs the simulation with these parts at 10 different sizes and then presents simulation results as kind of alternatives. Here's what your simulation results are if you were to design this assembly with that part at 10 different sizes. So it's a very useful real world simulation tool, and my test is timing how long it takes to solve those 10 studies. So that's that. The next test is this one here, which is a static study of an alloy wheel. However, I've changed this one slightly. MSI Afterburner kicked in. I've changed this one slightly since I've shown it in the last video. I've now edited intentionally the contacts in the mesh. So prior to the solver starting, the test has to update the contacts, so all the loads and all that, and it also has to update the finite element mesh before it actually starts the solver. So it's kind of doubled the time that this test takes to do, which is good. It's more tests within a test, if that makes sense. So I'm excited about that one. And yeah, these are all, it's a tire pressure load. So it's simulating the tire pressure on an alloy wheel. So that's a static test, parametric test. This is dynamic simulation, mate. This is a mechanical assembly, or it's simulating mechanical motion, kinematics, torque, acceleration, all that kind of stuff. So I've got 10 tracers on various points in this assembly, and I'm enabling the simulation player. And this test is timing how long Inventor takes to play this simulation whilst also simultaneously logging 10 or 12 data traces and showing it via this graph here. So that's dynamic simulation. This one here is the start of the test that you've not seen yet, and this is my graphics test. So obviously I have a graphics test in my Inventor benchmark test. As I've said numerous times over the years, Inventor is not graphics accelerated. It's not hardware accelerated. It does not use the GPU to power what you see on screen. This statistic here is how much of the graphics card is being used, currently 16%. If you don't believe me, keep your eye on that stat as the graphics test is being performed. That will never rise above 20%. It might spike once or twice, but it very rarely does. So I've got multiple graphics tests and multiple tests within the tests. So the first test, just take a shot how many times I say test. The first test is regular modeling mode, which is just normal textures, no shadows, no lighting, no reflections, just how someone would model in Autodesk Inventor. And then I'm performing like a figure of 8 orbit and then recording like the frames per second and then converting that into a meaningful number that I can benchmark. So that's what this is. Also the textures that I'm using. These are all high definition textures pulled from the Autodesk Appearance Library. So they've got bump maps, they've got grooves in them, they've got reflections, they've got normal maps. There's all kinds of weird and wonderful, wacky kind of textures that I've brought in. Just they're not realistic. You know, for example, on the nose cone, I brought in a metallic paint and I've absolutely cranked all the way up to the max, the orange peel effect, to an unrealistic amount, but you get that dimple effect as it's spinning around. The idea being, if someone's using a laptop from 1999 with CPU graphics with absolute terrible, inefficient VRAM capabilities, then it might give them a problem. And that's the idea. It's to make sure that you're benchmarking technology in a decent way where you're highlighting issues that some people might have with genuine models. So that's the first test, regular modeling mode. The second test is this one here, which is regular modeling mode, visible lines on the model enabled, but also hidden lines enabled as well. This one's seriously computationally expensive. So the frames per second drops down to 22 frames per second on this one. And it's visibly a lot slower. But notice obviously the graphics card's still 19% utilized. And then this one here, this is Wireframe, which I would suspect most people who aren't au fait with CAD would think Wireframe would be quite intensive, but it's not. It jumps up to sort of roughly 40 frames per second for Wireframe mode. And then the final test is the most intensive one. And this is all visual settings, all visual effects cranked all the way up to the top. Reflections enabled, ambient occlusion enabled, ground shadows, object shadows, and you can see the shine, all the materials. The bump maps are enabled. There's that orange peel that I was talking about there on that nose cone. And then I do the figure of 8 with the reflection and the shadow always sort of in view as it's being pushed through the figure of 8. So that's the assembly graphics test. I then jump into the part mode graphics test, which goes through the exact same sequence and settings of tests, but with a single part instead of an assembly. And on a 10900K, it is lightning quick. Watch this. This is how fast the graphics test on the parts take on 10900K. Blink and you miss it, and it's done. That's it. So yeah, it's about roughly 2.5 seconds to do the entire part graphics test on a 10900K. But yeah, there's the visual, the wireframe realistic mode. It's exactly the same visual with hidden edges enabled. And then the next test it's another graphics test, but done in a slightly different way. It starts out with a huge assembly. This is a massive it's not a massive assembly in terms of real world, but it's quite big in terms of what I can get people to download. It's roughly around 1,500 parts. So I do a regular orbit here as a baseline, figure of 8, regular modeling mode, no visual effects enabled, nothing like that. But then for the second part of the test, I'm selecting all of the internal robots here because, and a couple more parts in here, because of one of the, not a downfall as such, but one of the complaints that a lot of people have with Inventor and I guess any CAD application is when something's selected and then you perform a view command, it tanks quite a bit. So this is benchmarking the performance degradation when something's selected and then you do an orbit. So we're going from what is roughly 13 frames per second during the figure of 8 under normal circumstances down to around 8 to 9 frames per second whilst things are selected, which doesn't sound like big numbers, but that's a massive percentage drop in frames per second. And same for the frame time. We've gone from 75 milliseconds frame time down to 115, about 115 milliseconds frame time, which is a huge change. And that's on a 10900K. On weaker hardware, I'm quite excited to see the differences and the scaling that these tests have across different hardware. Because this currently, as things stand today, the PC that this is being run on is sort of best case scenario. And then this is the final test, the one no one's ever seen yet, that I'm so excited for. It's the ray tracing test. Now this went through a number of iterations over the last couple of months, really. Originally, it was going to be a ray tracing scene done within the Inventor viewport. So open up the model, go to view here, and then ray trace. And then I was going to time how long the bar goes across to ray trace the scene. However, there was all kinds of reliability issues with that. Windows display scaling, different resolutions of the monitor. I had to force the Inventor window to be a certain size. If people tried to cheat by setting their Inventor window to be, or if someone tried to cheat by setting their desktop, their entire PC to 800 by 600, then run the ray tracing test, I had to put in a mechanism to stop the test running if it detects their PCs at a resolution which is lower than the supported capabilities of their monitor and all that kind of stuff. And I was like, this is just ridiculous. This is a rabbit hole. I'm not going down there. And then clean screen as well. The ribbon bar was getting bigger and bigger with Windows display scaling, and the browser needed to be turned off. And I thought, no, enough. So instead, went away from that. And we're going into Inventor Studio, which, it's like Inventor Studio, come on. It's actually very, very good for automating a test. And the results are exactly the same as it would be in terms of benchmarking if we were to do ray tracing in the viewport. It's still all cores on the system going 100% to complete a task. And this is the only thing in Inventor. This is the only function in the entirety of Autodesk Inventor that will take all the cores on your CPU and max them out at 100%. So the scene that I've gone for is a custom scene that I've designed. It's 5 of my BMW alloy wheels, which I've patterned, and then I've created a custom scene with custom lighting in, it's not really a custom background, I've just edited it up. And the idea is time how long the workstation takes to ray trace 32 iterations of this scene. If no one's familiar with, or if you're not familiar with how Inventor does its ray tracing, it's not RTX based, it's not GPU based. This is unfortunately CPU ray tracing, and it's very unlikely that Autodesk will change that anytime soon. Because this is CPU ray tracing, the screen recording software just crapped its pants at this point and just pretty much stopped. So I've got a final image of the scene. So that's what it actually renders, and it doesn't finish because it's quite an intentionally intensive ray trace. So I've got 3 local lights at the back, brownie points if you can guess what those lights are. These local lights are bouncing around the inside of the rim, so we've got some sort of light leakage out of the back, which is computationally expensive, and we've got some light leakage around the front, things for it to calculate, and I've also got some extreme intensive depth of field going on as well. So I've got the camera focal point aimed around the front of the rim here, and then some bokeh kind of depth of field gradually phasing out, so we've got this sort of blurred effect, which, 32 iterations. There's still a lot of grain left in there, but any longer, and then if I'd put any more iterations in here, most people's workstations would have spent sort of 10, 20, 30, up to an hour, really, to finish just this one test, which isn't reasonable. So there you go. And that's the ray tracing test. FEA, parametric, static study, dynamic simulation, assembly test with 4 different modes, part orbit with 4 different modes, assembly orbit, then selection test, and then full ray tracing with depth of field and local lighting. And that's just 2 of, I think that's probably, I don't want to say how many more, I've got a lot more tests than that. There's a lot more than that. So at the end of this, you'll get 3 scores. Well, actually, no, you don't. I've got like, I don't want to say how many scores because that'll give away how many tests there are, but there's lots of scores, right? So there's 3 main scores at the end of this test. You'll get 1 big banner score, which is the InvMark score, right? That is the equivalent of like a Cinebench score or a like a Geekbench score. It'll be the InvMark score, and that's the one most people and should reference the workstation against other workstations. And that's the one that'll place it on the leaderboard. There'll be 2 direct subscores. That there'll be multi-threaded score and a single-threaded score. The multi-threaded score is a combination of how the workstation performed on the tests that leverage multi-core and multi-threaded routines. And then the single-threaded score is, of course, all the tests that were purely single-threaded in nature. And then underneath those, I've got a lot of tertiary scores, which are kind of granular scores for each individual test. So, for example, you'll be able to go onto the leaderboard, select a workstation entry, and see how it performed at the FEA test, or the dynamic simulation test, or the ray tracing test, or the graphics test. Each test will be given a numerical score graded based on how it performed. The idea being, you can go to a particular you can go to your workstation if you weren't happy with how the graphics score performed, and you can look at other people's laptops or other people's workstations to see whether yours is okay or not as good, or even just performing better than workstations that are roughly the same as yours. If you've bought a Dell 7550 laptop with a Xeon 10 885M Xeon CPU, you can go to the leaderboard and see, do other people with the same laptop have the same kind of scores as me? Is my laptop performing okay? Is it performing as it should? So that's what the granular scores are for, and as well as having the main score for the leaderboard. I've got it all under control, mate. It's all under control. It's all cush. I'm excited, mate. It's going to be awesome. It's going to be awesome. So we're nearly there. The leaderboard and the UI for the test itself, we're still working on designs for that. Once we've locked in a design, I'm pretty confident that those will be up and ready pretty quickly. I need to go through a short closed beta for getting some testing done, and then after that, I think we'll almost be ready for going live with this. So yeah, with the point of this being, I guess, I think those AMD CPUs, because the majority of Autodesk Inventor, even the graphics test, this ray tracing test, simulation test, they're all CPU bound. I think those AMD CPUs might be looking like they're going to be king of the hill. So it'll be interesting to see how many of those are topping my leaderboard when this all comes to fruition. So that'll do. Thanks very much for watching. Hope you're as excited as I am. If you are, let me know in the comments. The test is going to be free. There will be ad space being sold on the leaderboard. So if there's any OEMs, any brands out there that want to work with myself and Kadak for selling yourself, we've got space to sell on the leaderboard pretty much for monetizing this. So, but for anyone who wants to use this, the test will be free. It'll be available for Autodesk Inventor 2021 on day 1 only. Unfortunately, it won't be backwards compatible to older versions. But all of the bits and pieces around how to use it, guidelines and all that kind of stuff, that's all the formalities and stuff will be released as and when this goes live. But that'll do. Thanks very much for watching. I'll see you in the next one.